4. Did you read those pages about permutations? Question 2. In how many different ways can 4 people be seated in a row? So if I have 4 chairs, how many people to go on the first chair? I have 4 people. 1, 2, 3, 4. So I have 4 choices here, right? If I use person 1 here, how many choices left for over here?
3.
3, because I have 2, 3, and 4. If I pick person 2 for this chair, how many left for here? 2, and then for the last chair, 1.
So you add them up?
Well, you could add, subtract, multiply, or divide. I wonder which operation we would use.
Multiply?
Addition would be easiest,
Yeah.
but that's not the right operation.
Okay.
You'd multiply
Because
them?
I would have like 4, and then for each one of these, you see that? So it'd be that sequential counting principle. 4 times 3 times 2 times 1. Or that would be a permutation of 4 things taken 4 at a time. You follow that?
Wait.
So what's this say? How do I find that? That would be 4 factorial divided by 4 minus 4 factorial. What's 4 factorial? 4 times 3 times 2 times 1 divided by, what's 4 minus 4? 0 factorial. What does 0 factorial equal?
1.
Good. It equals 1. So that would be 4 times 3 times 2 times 1. So that's why this formula works. So do you want me to help you with problem number 1?
Yeah.
How many different orders can the letters in the set A, B, C, D be written? A, B, C, D. How many different ways can I write those? How many choices for the first letter?
4.
How many for the second letter?
3.
For the third letter?
2.
For the fourth letter?
1.
So that's a permutation of 4 things taken 4 at a time. So that would be 4 times 3 times 2 times 1. The same as my people sitting in a row. Number 4, in how many different ways can 7 people be lined up at the checkout counter in a supermarket? How many people? A permutation of how many people?
7.
7 people be what? Lined up at a checkout counter. So how many people are being lined up?
7.
All 7 of them. Permutation of 7 people taken 7 at a time. Or if I had 7 people in front of me and I'm the last guy here. 1, 2, 3, 4, 5, 6, 7. How many people to stand in the first slot?
7.
7. Then what?
6.
And that would be 7 factorial, which is what this is, divided by 0 factorial. You see that from using the formula?
Why do you have the factorial thing? Why? I thought you just multiplied them. Why do you need to bother with the factorial?
Well, I'm showing how this formula works. In other words, I'm drawing a picture of it here. And up here, I'm showing how this formula works. That would be a permutation of 7 people taking 7 at a time.
Okay.
And that would be worked, the way you would work that is following the formula, 7 factorial divided by 7 minus 7 factorial. Maybe I should have put that 7 minus 7 factorial,
Okay.
which would be 0 factorial.
What's the point of having a factorial? I don't.
Oh, that's just a symbol. This symbol right here, this symbol right here means 7 times 6 times 5 times 4 times 3
Oh.
times 1.
Okay.
That's what factorial means. And it's just a symbol for communicating mathematically with one quick little symbol what all of this is. Which is, you say, why that? Because that's what's going on here.
Okay.
So see here, I'm drawing a picture of people standing in line at the grocery store, and here I'm doing it using the formula.
Okay.
So you can see it both ways. Oh, by the way, what does that come out to be? 7 times 6 times 5 times 4 times 3 times 2 times 1 equals, what'd you get?
That's so handy.
There's a button on the calculator for factorial.
You have a button on your calculator for factorial?
Exclamation point.
What?
So you just push the number and then you push that button.
And then did you get 5,040?
For which one? For 7? Let's see. Yep.
Oh,
Isn't that
2
cool?
clicks of a button.
beautiful.
Technology's amazing.
Modern technology. Where did you get those calculators?
They're just on our phone.
What?
They're just on our phone. They come
On your
comes on our
iPhone.
phone.
How cool is that? How cool is that? Okay. So number 6. Oh, we'll skip that one because it builds on number 5, and number 5 is one you're working. So we'll go to problem 8. Compute the given number. What does problem 8 say? 10 factorial. Which means what?
Um,
10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And what does that come out to be? I don't have that on mine, so I'm going to have to just go 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 equals, did you all get this number? 3628800.
Yep.
3,628,800. So you can find the answers a lot faster than I can because I've got my little $1 calculator here, and you have your iPhone. So what about number 10? It says 10 factorial, and then what? Divided by 7 factorial. Well, that would really be 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 divided by 7 times 6 times 5 times 4 times 3 times 2 times. So you see how all that cancels out? And it's just 10 times 9 times 8. Okay?
okay.
Number 12. 8 factorial. Where'd it go? Divided by 2 factorial times 6 factorial. Now, you could take your factorial stuff and just do 8 factorial and get an answer. But watch what I'm going to do, since I don't have that capacity on mine. 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 divided by 2 times 1 times 6 times 5 times 4 times 3 times 2 times 1. So all this cancels. And I'm left with 8 times 7 divided by 2, or 28. Everybody see that? Number 14, permutations of 9 things taken, did it say 4 at a time? Yep. So, according to the formula, that would be 9 factorial divided by 9 minus 4 factorial, which would be 9 factorial divided by 5 factorial. You follow that? But watch how I set this up. 9 times 8 times 7 times 6. In other words, watch what I do. I start with 9, because that's how many I have, 9 things, taking 4 at a time, so I have 4 places I'm filling. So that just means I go 9 times 8 times 7 times 6, and I have the answer. Does that make sense to everybody? Good. What does that come out to be, just for fun? 9 times 8 times 7 times 6 equals 3024. So that means if I have 9 people in a room and I have 4 chairs in the front of the room, how many different ways can those 9 people sit in those 4 chairs? 3,024. Now, I'll just tell you that when I say that, that sounds too big to me. 9 people in the room, 4 chairs here in the front of the room, and there are 3,024 different ways to seat people in those 4 chairs? Yes.
What problem is that?
Number 14.
Okay.
So, not only do you have to know, I guess you say, I'll just use the formula every time because I've got a factorial thing on my iPhone that I can use. But do you understand that when you're doing that, if you're thinking about what's going on here I'm just kind of making sense out of it with 4 chairs, 9 people, and I come up with 3,024 possibilities. I suppose the way you would do it on your phone is you would just go 9 factorial and get an answer, and then go 5 factorial and get an answer, and then divide those 2 answers.
Okay.
So you kind of say, sometimes I'll use the formula, sometimes I'll just think it through. But if you're going to think it through, then that means you have to kind of understand the process. You have to understand what's going on rather than just plugging numbers in a formula. Number 16, permutations of, what's it say? A permutation of 6 things taken 3 at a time, divided by what? 4 factorial. So So this would be 6, 3 times 5 times 4. Everybody follow that? A permutation of 6 things taken 3 at a time, 6 times 5 times 4, divided by 4 times 3 times 2 times 1. So the 4's cancel, and I'm left with 30 divided by 6, which would be 5. Everybody see that?
Cancel the 5s here.
Everybody see how I got the answer? 5 for problem 16.
For example, in problem 13, would you only be able to cancel out one of the permutation things? No.
No, there's 3 of them.
No,
They're
like
not permutations for 13. They're just factorials.
factorials.
Yeah. So what does 13 say?
Well, it says
9 factorial
yeah,
divided by what?
5 and 4 factorial.
5 factorial and 4 factorial.
Yeah, and
So this would be 9 times 8 times 7 times 6 times 5 times 4, 3 times 2 times 1. And this would be 5 times 4 times 3 times 2 times 1. And this would be 4 times 3 times 2 times 1.
So can you cancel out the 5 with the 5 up there?
Up here?
Yeah.
Yeah, so I can go this and this, 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 and then 2 and 3 make 6, right?
Oh, wow. Yeah.
And then 4
It's half of 8.
is half of 8, so that becomes 2. So now the answer is 7 times 9, 63 times 2, 126.
that was more complicated than it needed to be.
That was what?
That was a little complicated.
So you're just going to go, watch. When you take your phone and go 9 factorial, what do you get? What's 9 factorial?
It's 362,080.
Say that again.
362.
62?
880.
880?
Yep.
And then I divide that by what's 5 factorial?
120.
120 times, what's 4 factorial?
24.
24. What's 24 times 120?
2,880.
2,000 and what?
880.
What?
880.
880? 880?
No, two-
So now I divide this by
No, by
880.
2,880.
2,880, and I divide this by this, and what do I get?
362. Oh man. 362, 880 into 126.
126, the same answer we got over here.
Okay.
Cool.
All right. Question 22. Suppose 10 people are entered in a race. Then as soon as they tell me that, I make a little parentheses and put 10 people that I have running the race. And there are no ties. How many ways can the first 3 places? So that's a 3 there. That's a permutation of 10 people taken 3 at a time. And what I want to know is who came in first, second, and third. How many people could come in first?
10.
10. And how many left to come in second?
9.
And how many third?
8.
So how many possible ways could those 10 people come in first, second, and third?
10, 9.
8 times 9 is 72. Times 10 is
106.
720. You see 10 people lined up to run a race, and you stand there and say to your friends, did you know there's 720 ways to get a first, second, and third in the race? And they go, what? You go, permutations. I studied them in math class at Calvary.
Oh.
That still seems like too big a number, doesn't it? I mean, in my heart it does. 24. In problems 25, rework 23. No, I'll let you do those. In problems 25 to 28, assume the cards are drawn without replacement. So I'm back to playing with cards again for problems 25 to 28. In how many ways can 3 hearts be drawn from a standard deck of 52 cards? So watch what I do here. I make my little parentheses and a comma, and where does 3 go? Over here, because that's what I want to draw, right? 3 hearts. From how many hearts are there?
52.
What?
50. Wait, what was the question? Oh, 4.
How many hearts are there?
4. 3.
Wait, there should
What's
be
the
like
question?
13 hearts, right? Because there's 1 through 10, and then there's a Jack, King, and Queen.
Oh, that's what I was doing.
How many hearts are there? 13?
Okay, that makes
13
sense.
cards with a heart on it?
I guess
Carissa doesn't play cards.
Apparently. No,
So,
no.
so it's like, so I have to figure out the deck of cards now to be able to do this. So I've got 13 hearts and I want 3 of them. So that would be 13 possibilities for the first one. What? 12 and then 11. 11 times 12 times 13. Or if you do the formula, that's a permutation of 13 things taken 3 at a time. That's 13 factorial divided by 13 minus 3 factorial, which would be 13 factorial divided by 10 factorial. You follow that? And you could just take your calculator and do the work, but do you notice 13 factorial over 10 factorial is really 13 times 12 times 11 times 10 times 9 times 8 times 7, 6 times 5 times 4. No, I didn't start. And move this over. 13 factorial divided by 10 factorial is 13 times 12 times 10 times 9 times 8 times 7, 6 times 5 times 4 times 2 times 1 divided by 10 times 9 times 8 times 7 times 5 times 4 times 3 times 2 times 1, which is 13 times 12 times 11. So sometimes if we just fixate on a formula, we create a lot of work for ourselves when we can just go, hey, there's 3 of them here, so I have 3 slots to fill. There's 13 possibilities, so it's 13 times 12 times 11. So sometimes I think it's helpful to just make sense out of a problem. 26, in how many ways can 2 kings be drawn from a standard deck of 52 cards? So now, I want what? A permutation of I want to draw 2 things from how many kings are there in the deck?
4.
4.
Gonna get it.
King of spades, king of hearts, king of diamonds, king of clubs.
Got it, that's right.
Now we got this thing going. So that would be what? 2 slots to fill, 4 for the first one, 3 for the second one. Didn't it say without replacement? Without replacement. So I draw one of them. That leaves me with 3 for the second choice. So there's 12 possibilities. Does that make sense to everybody? The first king could be king of diamonds, king of hearts, king of clubs, king of spades. Once I get one, I have 3 of them left for the second choice. That sequential counting principle says 4 times 3 is 12. Or you can do the formula. Since you have a factorial key on your phone. 28. In how many ways can 4 diamonds be drawn from a standard deck of cards? So now I want what? 4 cards. And how many cards do I have to choose from? Diamonds. How many cards have a diamond on them?
13.
13. So a permutation of 13 things taken 4 at a time. That would be 13 times 12 times 11 times 10. Okay? Number 30. How many even 3-digit numbers can be formed from the digits 2, 4, 5, 7, 9? With no repetitions. What are my digits? 2, 4, 5, 7, 9. And I want to form what? Even numbers? Is that what they said to do? Read the instructions. 3-digit numbers. Even 3-digit numbers. So that means it's going to have 1, 2, 3 digits, right? And it has to be an even number. So what does it have to end in?
A number that's divisible by 2.
Even numbers end in what?
2, 6, 2, 4, 6, 8, 0.
So if it's going to be an even number, I have 2 choices for the third slot, right?
Mm-hmm.
How many choices for the first slot? Okay, if I've already used one of these for the third slot, what's left for the first slot?
Any other number.
1, 2, 3, 4. I have 5 possible numbers to use. I've put 2 or 4 here. So what's that leave me for over here? How many numbers do I have left to put here?
4.
4. And how many left to put here?
0.
3. Everybody see that?
Yeah.
Didn't they say without
Right.
repetitions? With no repetitions. So see, that means once I put 2 here, I can't use it over here, so that only leaves 4. If I put 4 here, then I'm only left with 4 to put over here, and then after I use one of them, I'm left with 3 for here.
Mm-hmm.
So that's 3 times 4 is 12, times 2, 24 possibilities. Now, number 32. Well, it says in problem 31, a red die and a green die are tossed. In how many ways is it possible for both dice to come up even numbers? So I have 2 die. How many possible numbers for the first one And how many possible numbers for the second one? How many numbers on a die?
Well, there's 6.
6.
But
There's 6. But what if it said, what does probably 31 say?
it says if they want them to be even.
That they have to be, does it say, does 36 say they both have to be even numbers?
Yeah.
How many even numbers on the first die?
3.
3. How many on the second die?
3.
So the answer to your problem would be 9. You see that? For problem 31. So what about problem 32? How many ways is it possible for one of them to be odd and the other even? Well, now let's come over here. Here's our 2 die. And this number can be odd or even. Is that right? Is that what they said? So how many possibilities for here? 6, because it's odd or even. But then if this one is odd, this one has to be even. If this one's even, this one has to be odd. You follow that?
Mm-hmm.
So I have 6 possibilities for the first die. How many possibilities for the second die? 3. So the sequential counting principle says six times 3 is 18. The complementary counting principle. Did you read that on page 684? The complementary counting principle. The number of units in A is the number of units in the universe minus the number of units in the complement of A. Whatever that means. Did you see that there? Well, let's see if we can make sense out of what that means. If 2 dice are tossed, oh, let's just do one of yours. Out of 5 children, in how many ways can a family have at least 1 boy? 5 children. So they can have a boy or a girl, 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 and a boy or a girl. Agreed?
Mm-hmm.
So that's 2 times 2 times 2 times 2 times 2. So how many possibilities is that? 8 times 2. So the number in the universe is 32. You see that?
Mm-hmm.
Now, what does it say? At least 1 boy. So you could have a boy here and a girl, 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 girl. Or a girl here. Oh, you could have a boy here and a boy, 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 couldn't you? Because it says at least 1, so they could all be boys. Couldn't they? What's the one thing they could not be? All girls. You see that? So, at least 1 boy means you take the universe, 32, and subtract the occasions when there would be no boys. And that would be 1, wouldn't it? When you had all girls. You follow that? So what would that be? 32 minus 1 would be 31 possible ways to have at least one boy. When you see that word at least, then you go, I could have 1, I could have 2, I could have 3, I could have all 5, but the one thing I couldn't have would be all girls. If 2 dice, number 34, are tossed, in how many ways can at least one of the dice come up a 6? So you want at least one of the dice to come up 6. Okay, well, they give a hint there, don't they? There's 5 ways a single die can come up not 6. So what's 5 times 6? So not 6 would be 30. What's 6 times 6? In how many ways can at least one die come up a 6? At least one die. So that would be, I can have 1 6. I can have 2 6s. Maybe I'll draw a picture of that one. So I can have 6, 5, 4, 3, 2, and 1. And then I can have 6, 5, 4, 3, 2, and 1. 6, 5, 4, 3, 2, and 1. 6, 5, 4, 3, 2, and 1. You see what I'm doing? I'm making a tree here. And I want at least 1 6. Isn't that what they said? So all 6 of these would have a 6. How many of these would have a 6? One of them. How many of these would have a 6? One of them. How many of these would have a 6? 1. 1. So what would that be? 7, 8, 9, 10, 11. You see what can happen is if you're not sure how to plug numbers into the formula, you just draw a picture and build a tree and use the sequential counting principle. Number 36. 6 coins are tossed. In how many ways can you have at least one tail? At least one tail would be, what would be the time when you couldn't have at least one tail? All heads. And 6 coins. Heads or tail, heads or tail, heads or tail. What would that be? 2 times 2 is 4, times 2 is 8, 16 times 2 is 32, times 2 is
64.
64. So the number in the universe would be 64. So the number of possibilities would be 63. You follow that?
Wait. Wait.
Can you do number 37?
Is that 37?
That's 36.
Oh, okay. I was
So it's
confused.
It's in
For 37, you do the same thing. You just minus 2, right?
At least 2 heads. So, could you have 1 head?
Yeah. Wait.
No, you have to have at least 2.
At least 2.
Right.
So
yeah.
you couldn't have 1 head, and you couldn't have no heads.
So you
No heads
subtract
would be all
4?
tails, right? Right?
Yeah.
Okay. How many coins are we tossing here? 6? 1, 2, 3, 4, 5, 6. No heads. That would be tail, 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 tail. 1 head would be head, tail, 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 head, tail, 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 head. Follow what I'm doing?
Mm-hmm.
And you can't use those either. How many of those would you have? 6 of them, wouldn't you? 1, 2, 3, 4, 5, 6, where it's 1 head and no tails.
So you do 64 minus 6?
No, because you have to have 2 heads.
Plus the no heads, 64 or 60. What would it be? 64 minus
7?
7. Now look at number 38. At most 1 head. So if at most is 1 head, that would be 6, wouldn't it? But that would also include no heads, because it said at most. So that would be 6 plus 1 or 7 for number 38. Do you see how I'm making a little picture
Yeah. It also confuses.
helps you make sense out of it?
Mm-hmm.
Have your experiences in math been such that you go, I don't want to make sense out of stuff. I just want a formula to plug in the numbers and find the answers.
That's me.
See, if you were taught math that way,
That's all the time.
you should send an email to those people and say, shame on you.
I'll send an email to the computer program.
But isn't that right? I mean, if it's like just plug the numbers into the formula and get the answers, it's like, then I don't learn how to think about math and make sense out of stuff. So what are you going to do when you teach math to your little chippers? Are you just going to have them plug in the numbers in the formula?
No.
You're going to help them understand, aren't you? And see what's going on. I mean, even if you just plug in the numbers and do the formula, now that you understand how this works, doing the formula isn't as stressful because you understand what it is you're doing. Well, we've got one more thing to cover, the additive counting principle. What's this? Number 39. How many of the first 100 natural numbers are multiples of 2?
You know what I mean?
Counting numbers, 1, 2, 3, 4, 5, 6, 7, 8, up to 100, right? How many of those are multiples of 2?
2, 4, 6, 8.
8, 10, 12. How many would that be?
Half of them.
50. Agreed?
Agree.
How many are, what's the next question?
Or multiples of 5.
How many are multiples of 5? 5, 10, 15, 20. How many would that be?
1, 2,
25.
25?
Good job, guys.
Yeah.
I was not there.
I'm like, is this a trick question? I don't know.
I know. I was like, am I missing something?
25? How'd you get 25?
Wait. No,
I
not
don't
25. To 20, right? Right.
How'd you get 25?
You
I
just
don't know.
split 50 in half.
I don't know.
You just picked a number out of your heart that looked
5,
good?
Wait,
10,
wait.
15, 20, 25, 30, 35, 40,
20.
45, 50, 55, 60, 65, 70, 75, 80, 85, 90, 95. It's 20.
It's 20.
I said that in my head, and then she was
I
like,
did it.
But
by
see,
accident.
did you see what she was doing? I mean, you just take your fingers. And you know what? When I hold my fingers up and start doing that, when my wife used to watch me do it, she goes, Tom. I go, what? She goes, because she was an elementary school teacher. Were you ever told this? Don't count on your fingers.
No,
I don't know who told you people that,
Are you
but send them an
serious?
I
email.
never
You're
told them.
never allowed to count on your fingers. You get in trouble.
Why?
Yeah, it's like, is that sad?
And so we'd always try to cheat by holding our hand in our
yeah,
lap
that's
and going
right.
like
And
this.
it's like, hey,
would
if
tell
my
my
fingers
why
are
can't you
right
count your
there
fingers?
and they help me,
Why can't you count with your fingers?
I've always
Because
been allowed
that
to.
makes
That's
you
not a
lazy.
thing.
You're not supposed to do that. You get in
okay,
trouble.
no, you had a
Yes,
bad
it's cheating.
teacher.
What are your
Celeste,
fingers for?
If you remember who they are, send them an email and say, shame on you.
I can't really do that to my mother.
I
though,
did a
so.
math training for preschoolers, and they said that you should never make kids recount if they said the right answer because it'll affect the way that they see and can count. Does that make sense? So if you can see something and be like, oh, there's 3 things there at just a glance, you should never have a kid be like, well, let's make sure and count them again. Don't do that. It's bad for kids.
Wow.
Isn't that random?
See, now here's
I don't
here's
know.
what I would say when you say, here's what I would say to that. If some little kid in the room goes, how did he get 3?
That's true.
I'm going to
Then
say,
it is.
Johnny, tell him how you got 3.
Because then the one could teach the other one. And
Yeah,
get
then he's
it.
helping him learn
That's
this
a good
stuff.
time. Okay.
Okay, now let's get back to problem 39 so we can finish this thing. So there are 50 multiples of 2, 20 multiples of 5. So what does that mean? There's a total of 70? Because
It says or.
the addition principle, the additive counting principle on page 684 is the number in A union B equals the number in A plus the number in B minus the number in A intersect B. So I've got 50 here, I've got 20, but I have to subtract where 2 and 5 intersect, which would be what? At 10, 20, 30, 40, 50, 60, up to what? Up to 100?
10.
Because see, 2 is in 10, so is 5 in 10. 2 times 5 make 10, right? So I'm going, and that would be true for 20 and 30 and 40 and 50 and 60. So how many would that be? 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. What would I put over here?
10.
50 plus 20 minus 10.
Oh.
Is that cool?
60.
Mm-hmm.
Number 40. How many of the first 100 natural numbers are multiples of 2? We already have that, 50. Then what's the next thing say?
Or multiples of 3.
3. What would that be?
33. Right?
3, 6, 9, 12, 11, 12, 13.
Right?
How many multiples of 3 are there, people?
33.
Ladies, how many multiples of 3 are there? 3, 6, 9, 12, 15, 18.
21, 24, 27, 30, and we're done.
Oh, just
Get your hands together. You use both hands and your toes if you need to.
I'm not gonna do that.
And what do you come up with?
33.
33.
I love how Paris was actually over here doing it after you said 30 and we're done. I was like, okay.
And then 2 times 6, duplicates, 6. How many times will you find 6 in there? 6, 12, 18, 24, 30. You follow what I'm doing?
Mm-hmm.
So how many am I going to come up with? 36, 42, 48, 54, 60. You got 10 down?
Mm-hmm.
66, 72. What? 78,
Mm-hmm.
84,
Mm-hmm.
90,
Mm-hmm.
96.
96.
And there's not another one.
That's it. So what do we have? 16?
10, 15, 16.
So minus 16.
Love math.
So 50 plus 33 minus 16.
Do you like geography?
And you know what else? If you're teaching this to little kids, do you see how much practice they get? I mean, we've all learned to count by 2s. 2, 4, 6, 8, 10. Have you learned to count by 5s? Yeah, 5, 10, 15, 20. Have you learned to count by 3s? Well, not as well. But see, 3, 6, 9, 12. Can you count by 6s? 6, 12, 18. And you can have them write it out on paper, and it's just helping them develop their mathematical abilities. Number 42. How many license plates using 1 digit followed by 3 letters and then 3 digits can California issue? What am I going to do here in California? Let's draw a picture of this. I'm going to make a license plate that has what? 3 digits? Whoops. 3 digits? Then what? What's it say for 42?
Using 1 digit followed by 3 letters and 3 digits.
1 digit. Oh, 1 digit.
So that would be
Here's 1 digit
7.
followed by 3 letters. And then what? Where'd it go? And then 3 digits. You got the picture of how I'm making license plates in California? And A, repetition of letters and numbers is permitted. So I can repeat. So how many digits for the first digit?
9.
1, 2, 3, 4, 5, 6, 7, 8,
9.
9, and 0.
Mm-hmm.
Can I use 0 or did they tell me not to?
Yeah, you can use 0.
So
Yeah,
then I
it's
have 10 for this one. Then how many letters? How many letters in the alphabet?
26 or 27.
Do you know?
26.
26?
No, 27.
Well, let's count them.
6.
A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T,
26.
U, V, W, X, Y,
And
Z.
Z.
26.
26. Siri was right.
26, 26, 26, because I can use repetitions. And then 10, 10, and 10.
Oh my, this is gonna
And I
be
multiply
a
all
big
those
number.
numbers.
It's gonna be huge.
Well, it's a good thing because California has a lot of people.
Does that mean that somebody could have a license plate that says, like...
You see how you just draw a picture of this stuff?
Uh-huh.
And then just do the sequential counting principle? So can you do 43? 41? Can you do 41? Oh, wait a minute. We didn't finish 42. What if you can't repeat letters or numbers? No repetition. So that means I have, what, 10 here, 26 here, but then I have, what, 25 and 24. And then if I've used one of them, then I have 9, 8, and 7. You follow that for no repetitions? Because for your problem, Vermont doesn't have as many people as California, so they just use 6 digits.
Mm-hmm.
Which would just be 10 times 10 times 10 times 10 times 10 times 10. When it's permitted, when it's not permitted, 10 times 9 times 8 times 7 times 6 times 5. Okay. Can you do 43?
43.
I did a permutation of 26 and 4. Is that right?
Which one?
For 43?
What the hell
Are you saying 41 or 43?
Which one are you working on?
I was saying 43.
43. Okay. They use 4 call letters starting with K or W. So if they have 4 call letters,
There's 26 possibilities.
then I have 1, 2, 3, 4. But they start with K or W, right?
Oh.
So I only have 2 possibilities here.
Just think that was.
No, you didn't read that part, did you?
Nope.
And you can't have repetitions. Did you see that? No repetitions? Did you read that part?
Yeah, but it didn't make.
So that means after I've used one of the letters here, I have how many left for here?
What?
20 what?
Wait.
How many letters in the alphabet?
26.
So I have
25.
25 and then 24 and then 23. Because I can't repeat the letters.
So then you multiply all those together?
Yep. 25 times 24 times 23 times 2. So how many radio station call letters are out there? 25 times 24 times 23 times 2 equals 27,600 radio stations. I think they have enough call letters for all of them.
We have a tornado drill today.
10
Okay.
o'clock. We'll be in class. That'll be fun.
Great.
I wonder where a tornado
Stop at 43.
This is lost. I'm gonna get this one.
And
So behind.